Hey there guys, welcome to my channel. Today we're going to be solving another nice Diophantine equation where we have y squared equals x times x plus 1 times x plus 7 times x plus 8, and we're supposed to solve for integer values of x and y. So in order to do that, let's go ahead and first of all multiply x by x plus 8 and multiply x plus 1 by x plus 7. So we're going to have y squared equals x times x plus 8 is going to be x squared plus 8x. And x plus 1 times x plus 7 is going to be x squared plus 8x plus 7. Cool. Now, if you look at this, you can see that x squared plus 8x is repeating. So let's go ahead and replace this with something like t. From that, we can say that y squared is t times t plus 7, which means that y squared is t squared plus 7t. Great. Next, let's go ahead and assume that t is greater than 9. In that case, if I add t squared plus 6t to both sides, we're going to have t squared plus 6t plus t is greater than t squared plus 6t plus 9, right? And from that, we will have t squared plus 7t, which is y squared, is greater than t squared plus 6t plus 9, and that can be written as t plus 3 all squared. So if t is greater than 9, y squared is greater than t plus 3 all squared. Next, notice that if t is greater than 9, we can go ahead and say that t squared plus 7t is less than t squared plus 8t plus 16. Again, t squared plus 7t is y squared, and t squared plus 8t plus 16 can be written as t plus 4 all squared. Great. So let's go ahead and put these two together. So we can say that if t is greater than 9, y squared lies between t plus 3 squared and t plus 4 squared. Cool. But notice that t plus 3 and t plus 4 are two consecutive numbers, which means that t plus 3 squared and t plus 4 squared are two consecutive squares. And that makes it impossible for any square, such as y squared, to be between these two consecutive squares. For example, we don't have any square between 36 and 49, right? So this is impossible. Therefore, t cannot be greater than 9, and therefore, we can say that t should be less than or equal to 9. But remember that t is x squared plus 8x, so x squared plus 8x is less than or equal to 9, which means that x squared plus 8x minus 9 is less than or equal to 0. Now we have a quadratic inequality. Let's go ahead and factor the left-hand side. So if you do that, we're going to have x minus 1 times x plus 9 is less than or equal to 0, which means that x lies between -9 and 1. But remember that x is an integer, so we want to solve for integer values of x. Therefore, we have 10 cases for x. X equals 1, or x equals 0, or ... x equals -9. So we have 10 cases for the values of x, but we don't know which of these values are valid. So to find out which one is valid, let's go ahead and take a look at our original equation. So our original equation was y squared equals x times x plus 1 times x plus 7 times x plus 8. So notice that on the left-hand side, we have a perfect square. So we must have a perfect square on the right-hand side as well. So we want to find the x's that would make the expression on the right-hand side a perfect square. And those x's are the valid solutions for x. So let's go ahead and check each of these 10 values and find out which one of them will make the expression on the right-hand side a perfect square. So let's go ahead and start with x equals 1. If x equals 1, then we can say that y squared is going to be 1 times 2 times 8 times 9, and that is 144. And fortunately, 144 is a perfect square. Therefore, x equals 1 is a valid solution. And from that, we can say that y is either 12 or it is negative 12. Sorry about my voice. Next, let's go ahead and test out x equals 0. If x equals 0, y squared is going to be 0, which means that y equals 0. Next, if x equals negative 1, we're going to have the same thing. Y squared is going to be 0, which means that y equals 0. But if x equals negative 2, we're going to have y squared equals 60, which is something impossible. 60 is not a perfect square, so we don't have any solution from this case. So x equals negative 2 is not a valid solution. Next, if we replace x with negative 3, we're going to have y squared equals 120. Again, 120 is not a perfect square. Therefore, x equals negative 3 is not a valid solution. If x equals negative 4, we're going to have y squared equals 144, which means that y equals 12, or it is negative 12. Next, let's go ahead and replace x with negative 5. So we're going to have y squared equals 120. Again, 120 is not a perfect square, therefore we don't have a valid solution from this. If x equals negative 6, y squared is going to be 60. So again, we don't have any solution from here. But if x equals negative 7, y squared is going to be 0, which means that y equals 0. If x equals negative 8, y squared is 0, which means that y is 0 as well. And finally, if x equals negative 9, y squared is going to be, again, 144, which means that y is 12, or it is negative 12. Cool. So we found out 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 pairs of valid solutions for x and y. And this should bring us to the end of this video. Thank you for watching this video. Please consider subscribing for more contents like this, and hit the like button if you enjoyed watching this. Hopefully I will see you later. Goodbye for now.